In the trapezoidal rule, we have a function that we want to integrate from A to B, but maybe it's too difficult to integrate by the techniques that we know. So what we want to do is to cut this up, this interval from A to B, into a few pieces, and then we'll create these trapezoids. We'll connect these lines, straight lines here, and we create trapezoids out of them. So if we take this trapezoid, then this distance here is the height of the trapezoid. So if we were to lay this over on its side, it would look kind of like this. And then, so this is the height. So that's here. Okay, so here's our formula. That's the height. And then base, one of the bases is the shorter side. That would be that one. So here. And the other side is here. Base. So we can find all the pieces. Here are the pieces. This is base, first base, second base, and then we divide by 2. And all of this is the height of the trapezoid. So if we do that for each one of these trapezoids, and we add them all up, then, and we combine it all into one formula, then this is what we get. So this is the 1/2, and then b minus a over n. That's the height, and all of these f values are the bases. So let's look at this example. We can integrate this by hand, but we'll use our formula here for the trapezoid. So integrate square root of x. So we want to go from 1 to 5, and we will make n equals 4. That means these little sub-intervals, we'll have 4 of those. And if we connect these with straight lines, then we have 4 trapezoids. So the first thing we need to do is to find the length of each subinterval, and that is b minus a, that's an a, over n. So this is b, this is your a, and there's your n. So the length, to make the numbers nice, the length of each subinterval is a 1. And now we need to get the x values. So this is my a value. We always start with that one. And then take the length of each subinterval. So 1 plus 1 gives me the next x value here. And then plus the length of the subinterval. So 2 plus 1, and then 3 plus 1, and 4 plus 1. So we have our x values. But really what we want are these function values here, the heights, which in turn are the bases of the trapezoids. So what we want to do is take each one of these x values, plug it into the function that we're integrating, the square root of x. So plug 1, 2, 3, 4, 5 in. So we have these function values. And then we take the function values, plug it into our formula. So we know b, we know a, b minus a, 2 over n. And then these are the function values that we just found right here. So we plug these values in. Now notice you have a coefficient of 1 here, but then you have a coefficient of 2, coefficient of 2, coefficient of 2, then the last one's coefficient of 1. So we just plug all that into our trapezoidal rule, and then we get an approximation of 5.19 for this area. the area from 1 to 5, or the approximation of that integral. Now the second method is called Simpsons rule. Simpsons rule is an approximation method. You see the little squiggly lines here. But what it uses is the area under a parabola. So we can kind of connect those three dots here and find the area under the parabola. There's a simple way to do that for the calculus, but I won't go into that detail. But the formula for Simpsons rule turns out to be right here. So if we take the same integral, the 1 to 5, get rid of that, square root x dx, and we want to approximate that using Simpsons rule. Well, the nice thing about it is we can use the same three steps we used up here. Step 1, we find the subinterval. So b minus a over n. Find all the x values, so a and then plus the subinterval length to find all the x values. So we find the function values same way. Take your x values, plug it into the function. And then instead of plugging the f values into the trapezoidal rule, we'll plug them in here instead. Just be careful that you notice you have a 1 coefficient, you have a 4 coefficient, then 2, then 4, then 2, then 4, and then your last one's a 1. So if we plug that in, so b minus a over n, you have a 3 on the bottom. That's just how the algebra works out. 4 is your n, and then here are your function values. And again, pay attention to the coefficients that are in the Simpsons rule. And if we punch that into the calculator, we get 6.79. Again, that is an approximation for the area or under this curve or this definite integral.